Hello YouTube, and in this video I'm going to show you, give you an example of how we modelled artificial intelligent agents to broker jobs between machines and end consumers in a 3D printing distributed network. So I was a lead investigator for the Brokering Additive Manufacturing project, which is the website's on my screen here. And the idea was that to look at how we can distribute work across 3D printers and additive manufacturing machines that are in people's homes, are in makerspaces, in schools, universities, all the way up to high-end, advanced manufacturing industry, such as the metal AM printers that are printing parts for automotive and aerospace industries. What's beautiful about them is that most of the CAD, the computer-aided design, creating the geometry and then creating the manufacturing code is an entirely digital process. So you could create the digital CAD geometry, put it into your slicing software, and then straight away you've got this kind of manufacturable code that you could then pretty much ship to any of those manufacturing devices. Some of them have slightly different flavors, but that's all accounted for in the software. So what we wanted to do is have this means of talking, these machines talking and saying, hey, I'm here, I'm available in this region, and I would like to print some items. I might just spin this video as I'm talking, and the jobs are saying, hey, I'm here and I'm available, I'm in this region, can we do a deal? And that was the idea of this brokering these networks. The reason we wanted to do this kind of agent-based approach is that, again, these machines are owned by lots of individuals. So a kind of top-down, typical facility management model doesn't really work there, because, of course, you kind of have to give away ownership and control of that machine to this central server that then distributes those jobs across a range of machines. So we wanted to have the machines to have their own ownership. You can then configure and set the settings within those. So things like, and what we're doing is demos, simple things like shortest print time or longest print time. But in this project, we're looking at a little more advanced artificial intelligence techniques to explore which ones are the optimal jobs to select and bid for, and also look at those kind of bidding and cost models. So they are able to think about, what's the best potential profit margin, or should I go for a shorter job during the day because my technician is available next to me who can then take the job off my machine and reset me, and then having a longer job over the evening where I want to be just running when no one is in the vicinity. So like I say, yeah, we've coded this up in a fair few different languages. Like I say, we've got a full proof of concept living lab, or so we've got it running on real machines in our lab, with students submitting jobs to it. That's all on GitHub, and that was all written in Node.js and JavaScript, which is all in your browser. So it's an entire browser solution. It's a matter of actually linking your machine to the browser to actually join the network. So we've created models using JavaScript, because that enables us to almost port that logic and code straight into our real world platform to test and validate against. We've written it in Python for larger scale models, and to run on kind of HPC software, and also to take advantage of all those machine learning toolboxes that are available, and the scientific toolboxes that are available in Python. And then if into some really large scale models and we need that extra little bit of speed and capacity, then yeah, we've been looking at some kind of Rust based models. So today, we'll just do a TypeScript one, or in JavaScript, and maybe there's will be a follow-on video showing pretty much the same thing in the other languages, just so how easy it is and portable this kind of modeling is, a technique, and hopefully it might be useful for you if you wish to do some agent-based modeling of these kind of supply chains. So if I drop it out of the window and just get up my coding screen. So what I'm using here is VS Code, and it's using Windows Subsystem for Linux. So this is just my terminal window here, using the Windows Terminal app. And I'll make sure I turn off the sound there in case of any emails. And what I've got here then is just a blank screen. in the bam.typescript.example folder. So I'll put this on GitHub so you can follow the code along. So what we want to do here is just like kind of initialize the package. Say it's package of code that we want to run. So I'm using pnpm as my package manager. So I just do pnpm init to add all the packages that we might need to run our model. And what we're going to be using to run this model is actually most of the core packages. There's not much beyond that, apart from the TypeScript, which is like a kind of superset over JavaScript that enables us to type our variables and check whether we are conforming to what we expect the values to be, whether it's a number, or it's a float, or if it's a string, those kind of things, or it's an array. So if we go and just add those dependencies, so pnpm-d add, what we need is the node types for just base node script. We want to use install tsx. That's going to be our way of running the code without having to compile it, because that runs TypeScript straight off, and actually TypeScript as well. Oops, if I can spell. There we go. So this will then go off to the internet and fetch and grab those packages for us. Fortunately, I've already got them cached. That's what pnpm allows us to do, is caches all those packages, so they just automatically get installed for us. Clear that, and as you can see, we've created that node modules folder. If you're familiar with JavaScript, that's where all your external packages are stored. And it's created a pnpm.log file, which is the specific versions of those files. So that's where they are all there. Okay, so one other aspect we want to add as well is I use Prettier to keep my files all nice and clean as I code away. So I'm going to add a Prettier rc.json file, and this is just going to say, so I've got some automatic commands in VS Code that will automatically format it, or format on save, using the Prettier tool. So I'm just going to give it some configuration here. So we're going to say created this JSON file, given the schema prettier.rc, so we know when we're starting to write it, give us these hints. So I want the width to be maximum of 80. Use tags, I will set to true, and no semicolons. So I'll set that to false. So that's just, again, just for code syntax. That could be anything you'd like, whatever preferences you have for your code. We'll then also do a tsconfig.json file, and this is going to just set up some details about what to look for in our TypeScript when we're coding. So in here we're going to do our schema and say it is a tsconfig. Oops. There we go. So it's going to be a tsconfig file. We're going to do compiler options, module, node next. So we're going to use the most up-to-date version of Node. And actually, I've got Node version 20 I'm using at this time. And node next as well. So that's all those. And then we're going to say no emit, because we're not going to try and compile this code, because we're going to run it straight through with TSX. And that should be most of our tsconfig files. And then we can go and create, I was going to go create the models folder. So this is where we're going to store the base models for our code, and then we can have like an experiments folder where we'll import those models into our experiments and just run those to do our different tests that we might want to run, or run a series of tests. So we go into our models, and what we've got in essence in our project that we're using, we've got this idea of this central broker, which represents our server in the cloud, or multiple instances of that server, and it effectively becomes a peer-to-peer network where agents, be it a job or a machine, will join that broker and send messages between them. So we're going to have to create this broker agent that does the message passing, and we like to capture some of those analytics of how many messages were sent and received and passed on, and how many messages have to be stored and passed. So it gives us a little message history if we want to diagnose how they communicated with one another. We'll have an base agent class then that we then extend to represent a machine or a job. So the first thing we want to do is set our agent, and we'll create a new file called agent.ts. So this is going to be our base agent class, and we're going to say and we are going to start with an export enum agent types. So we're going to say there's just a couple of different types of agent. One is going to be a type job. One is going to be a type machine. So we're going to say there's going to be different types of agents, and that's how we're going to be able to differentiate them because of this enum. Then we're going to export a class agent, and the class agent has an ID, and that's going to be of a number. It's going to have its type, which is going to be that agent types that we've defined up above. So it's going to be either a job or a machine. We're going to have a link to the broker agent, which we will leave as any for now, because once we've created it, I'll come back and update that. We're going to have some variables which are going to be useful to us, which is the sent. That's a number equals messages received number. I'm going to set that. So those are just going to capture some analytics for us, some useful information. We're also going to have a debug flag. I'm going to have that as a boolean, and we'll default that to false. So those are the some default bits. So we know we're going to have a unique ID for each agent. We're going to know what type it is. We're going to have a reference to the broker so it can send and receive messages, and that's going to be given to the agent on instantiation. And then we've got a couple of variables to monitor some analytics, and then the debug, so we can then log commands if the debug is true. So what we want to do is create our constructor. We're going to have the ID, so we're going to give it an ID when we make an agent. We're going to give it the type of agent, typed agents, and we're going to set the debug. That's going to be a boolean, and it equals a false. So, oops, mistyped there, number. And all in this constructor, we need to do is this.id equals ID, this.type equals type, and this.debug equals debug. And what we're going to have in here as the base, we're going to have a connect to broker. So we're going to simulate the idea of this agent connecting to our server, and we're going to call it any for now, type, and we'll do to do connect to broker. Okay, so there's going to be a function here. Once we've created a broker, I'll come back in, and we're going to then say like messages sent to the broker will be +1, so we're going to simulate us sending a message, and messages received, we'd expect to get one back to say, hey, well done, join the network. We also expect all our agents to have a handle message. So we're going to start creating some messages. We'll call that any for now, and then we'll do something. You know, the agent will have to deal with that message when it receives it. And there's also going to be a next function. So what's going to happen is we're going to have this kind of global time. We're going to be iterating through time, and for each of those agents we're going to use the next command to do any operations that that agent needs to do in that time step. And then also on the fly, if it receives a message, it will do the handle message. So when a broker forwards on a message in a given time, it'll handle that message in that instance. So those are the base bits for the agent. Like I said, we've got a couple of things that are missing right now. We've got a broker that we want to create. So we'll call the broker. We want to create also a global. I'm going to call it globals for now. And that's going to be storing our global time. So so we can access that global time. Sorry, let's export. I'm going to call this export global time. We'll just default it to 0, and we'll also export a function increment. Instant increment time, and that way just global time +1. So we'll be using that in our for loops. You'll see when we iterate through time, we're just incrementing the global time for our model. Right, to our broker. So broker, we might do the message first because we talked about messages, and it's quite involved in just checking the code. Has a lot of messages passing through, so we need that message type before we build out that broker, I feel. So what we have is export enum message type. So we're going to have different types of message. And in these models and the modeling we've done, we've had all different types of messaging and negotiation protocol. In this one, we're going to treat the jobs as kind of static entities. They just respond to the machine's requests. They don't do any bartering here. The machines will just say, hey, are there any jobs available? The jobs will respond and say, yes, I'm available. The machine will say, I pick you, and the job will say, yes, you can because I haven't been chosen, or no, I have already been chosen. So they're just very much more submissive in that way. They don't barter back in this model. So to do that, we have 6 message types. We have job available. Job is available. So that's when a job is responding to a machine to say, yep, I'm available to be used. We have machine is looking for jobs, and I'll manually add that in here, is looking for jobs. The reason why I tend to manually add the text itself is that I know what to expect when I'm printing these to the console. Oh, I need a comma there. So that's machine is looking for jobs would be the kind of the first message that it's going to send out to the broker, and the broker's then going to send that on to any available jobs. So machine has chosen the job. So the machines will wait for a period of time for jobs, and once it's got this kind of list of responses, it will then select one based on a logic that we're going to set. And we're going to have the job has accepted, machines offer, and we're going to have one that says the job has declined. So that may be that in between the time that the machine had to make the decision and sent the message, another machine may have got in there first and requested that job. The job has client machines offer, and then we'll do job complete. There we are. And then we'll export an interface of what our message structure is going to be. So we're going to define a type called message. We're going to give it a thread. So when a job starts sending a message, so machine is looking for jobs, that'll start a new thread of conversation. And as researchers, it's quite interesting to see how those conversations unfold. So having the thread as an ID is a good way of just tracking that through our models. We're going to say it's from and to, and they're both going to be numbers, and they are going to be the IDs for each of the individual agents. So agent type, this is going to be to agents. So we're also going to add in a bit of logic here where when agent types, if it's from a person but it's going to a number -1, because we're not going to have IDs, we're going to always have positive IDs for real machines. A -1 we're going to use here as a to all, and the agent type we're going to go is to which all. So is it to all jobs or to all machines? In this example, we're just going to be doing to all jobs, but that gives us that flexibility there. We're going to have a send at, and this is going to enable us to send a message in the future or in the next time step. What we're going to do is start building out like a message queue in the broker, and they are going to be able to append those to send out. And that enables us to kind of manipulate the send dates, just to manipulate. One of the things that we've been studying is how lag within a system affects a agent's ability to respond to requests and to be chosen within the network. We're going to have the subject, which is going to be one of our message types. And then the body, at the moment, we're going to keep it quite generic. We'll just say of type any. In more extensive models, you'd have, you could tie that with the message type. So, like say when say a job is available, that will, and we'll do in this demo, it will send some information about the job, say print time. You could couple those together to be a bit more structured and type sensitive. So with that, we can like create our broker now, because I think we're going to be using that a lot. Couple of things that we might want. We're going to import, or we'll import them along the way because it should automatically appear for us. We're going to create this class broker. We're going to act as our central server. We're going to have going to be a number, some messages received. These are going to be some statistics for us. Messages received, messages sent. We're going to have an address book. I'm going to call it address book, which when a agent joins, they go and get appended to the appropriate address book entry. So what we're going to do here is going to say it's going to be a key value pair, and the keys are going to be of the agent types. So we're going to have a machines key and a jobs key. And in there, we're going to have another a dictionary of key, and that's going to be the number. So that's going to be the ID, and then it's actually going to have a link to specifically to the agent. There we go. Whoops, not of HTTP agent. We want our own agent from here. And I just need to remember that the import needs to have our .js there. So just double check this. That's it. I remember to include a .js. So where were we? Broker. So now we've got an address book, and we're going to define that. Start off with. We're going to have a machine with no machines attached, and job with no jobs. So it's just an empty broker. We're going to have our usual debug flag. We're going to call that false for now. So and then we're going to have our message buffer, as I like to call it, which is just going to contain all our messages that are going to be sent to and from. And at the moment, in this case, we're not going to flush that buffer at all. We're just going to keep appending to it for the demo. But you can imagine once we've dealt with all the messages from a day, we can then remove them from the global time, move them from the model so our RAM doesn't go shooting into the sky. This is going to be type number, so the key is going to be the global time, when that message should be dealt with, and we're going to use our messages for message.js, and it's going to be a list of messages that they can append to. And of course, we're going to start with no messages being sent. Now we're going to create our broker. A boolean equals false. Oops. And we're just going to say this.debug equals debug. Now this one needs a next command and to handle any connections, receivings or disconnects from our agents. So we'll do the next command. So this is going to be called every iteration for global time. And we're going to check global time. So if global time, that's going to automatically import from our globals.js folder. And if global time is in this .message buffer, so it's going to say, do we have any messages for that given time? We're going to grab those messages from the key global time. And now we're going to do a for loop across those. So we're going to iterate across those. So we don't need the ID, but we need the message of messages entries. So we're going to go loop for each of the entries in that array. And then if the message.sendat is equal to global time, which it should be, that's why it's in there, but it's always good to double check. And we are going to do, and actually we could put flag an error there because it should never get to that stage. And then if message 2 is equal to -1, then that is a to all message. So what we want to do is go to for const. For constant, we're going to iterate now through each of the agents of object.entries this.addressBook. So it's a bit wordy, this one. Message.agent types, agent type. So in there we specified the agent that this should be going to, this message should be going to. So we're just now going getting from the address book all the agents, and then we're running through that key value pair. We're just pulling out the agent because that's all we need, and then we can go this dot messages sent. We've sent a message, and then we go agent handle this message. So now go and do that function or the operation that agent needs to do when it receives a message. If it's not, then it's definitely a directed message. So we need to then iterate through the two address sets of address books. We've got effectively two address books: the machine addresses and the job addresses. So this is entries this.address book. So we're going to go either jobs first, then machines. If we're going to check in that address book, if that message.2, so does it have that key? then agents message to dot handle message. So we're going to pass it that message to deal with. And this net message is sent again. That's equals 1. And we can break that early. Say, yeah, we've dealt with that. So let's say we look at the jobs first, and it happens to be a job message. Then we can exit early because we don't need to look at the machines message. It is quite heavily indented there. It could be cleaned up a little bit. And then here, actually, at the end of this, you could imagine at the end of that point in time, we could then go, right, all those messages in that from that day, we don't need any longer, so we could clear them from the memory. But today, for this demo, we'll just keep it as is. So what we want to do is now create a connect function. For this is for agents that are connecting to the network. Okay, so we're going to say agent. So here's the agent that's connecting. We can put a nice if statement here just to say if we're in debug mode, let's console.log the operation. So we can let's print out global time. So what time this happened? We'll say the broker add agent.type and the agent.id connected. So that's just going to tell us that an agent connected to this time. Then we can do this.address book. It's going to have agent.type. We're going to add them to the address book. Agent.id and equals the agent. And of course, we assume as we're simulating this is a backward and forward exchange. We'll say, oh, we received a message from them to connect, and of course we'll send one back to say, yep, we acknowledge your connection. We go. And we can do a disconnect ID. This time we're just going to get, well, we can have pass it the agent again. The agent can pass itself. There we go. And this dot message is received. And then we just need to do the same thing again. If what we can do here actually, yeah, is get the book. Let's do credit book, and it's going to be this dot address book agent.type, and then we're going to say just double check if book ID agent.id, if it has that ID in it, then we will just add a debug to say where you've recognized that someone's disconnected. So I'll just copy and paste this bit of code up here where we've just printed out that they're connected, and we'll just do exactly the same. Oh, there we go. And we'll just say they are disconnected. And then we'll delete the agent from the book. Break. Oh, agent ID. Oh, we don't need to break because it's not a for loop, aren't I? So I'm just using previous code that had a for loop there. And that's okay. And now we have one more function to add to here. That's receive a message, type message. So this is what we're going to, when some agent sends us a message, it's going to go to receive. And we're going to say messages received, that's one. If what we're going to do first, check it's not if message, if not this, oops, exclamation mark, there we go, if this dot message is buffer message dot send at. So if we don't have that date already in our message buffer, then we've got to create it. So that's going to, we've got to create the date. And then if it is, well, or if we've just created it, then we can just then send that dot push. We're going to add that message to that list. Oops. Push message. There we go. And this is quite efficient then, because if we don't have a period of time where we don't have any messages sent, we're not having to iterate that message book every time. It's just going to automatically just check if it has a message buffer, and for it, if not, then it's just going to iterate through much quicker. It's going to just avoid having to deal with that. And that's our broker. So it's dealing with any connections to agents, disconnections to agents, receiving any messages from agents. And the next function is the idea of, well, I've received the message, I'm now going to pass it on at the time that's the agent specified. So typically that'll be just the next time step. But like you said, if we wanted to manipulate with the lag or play with the lag, we can add that little bit of randomness to the code. So that's the that broker all done. So now we really need to create the job and the machine agents that sit on top of the agent here. But I guess, like I say, I'm just waiting for time. What are we doing? Okay, yeah, 40 minutes in. So let's see if we can just create, I think, a experiment entry and just load in the broker. It should be able to just load in because there's nothing else it needs to link to, and just get that set up, and then we can continue on by building the job and the machine in the next episode. So let's create a folder called experiments, and call it experiment 01. And what we're going to do is be able to import our broker, the models.broker. Remember that is .js. And then we can do constant broker, broker, new broker. And we're going to also import, say, increment time. Oops. Globals, and we can set global time. And what we'd like to do is just do a little for loop. Let's just get some time running, just to iterate for that broker. So let's say for I equals 0. Oops, that's a const. There we go. I less than 100. So just going to do I plus. Okay, and I think that's going to have to be a let, isn't it? Of course. There we go. So we're going to increment time now. What we would do is, because it starts at 0, we'll put increment time in here. It's a function. Let's console log global time just to see what's happening, and we would then run here broker dot next. Actually, we could set the set this to true. So we'll set the debug to true, because nothing really going to happen here. We're just going to see hopefully the broker just did satiate, and then this is going to loop, and we're just going to have a list of 100 values be printed out. So what we want to do is then show how to run this. Just for easy, I'm going to keep this in scripts. So let's call this one experiment 01. And what it's going to do is tsx experiments / experiment 01.ts. So then to run that, we should be able to do pnpm experiment 01. And there we go. So it's all good. So there we go. We've just printed out a load of values. So we've just instantiated this broker that's got no agents connecting to it at the moment, and it's incrementing that global time. We might want to have a set time function if you want to not start at 0, but normally it's always good to start at time 0. And it's just that increment time is incrementing every step, and we're getting that reported back. So I think we should leave it there. So the next episode for this, next video, we will now continue on doing the job and the machine agents, and that'll probably pretty much wrap up the example then, because then we'll be able to put those in and show how they then bid for work, because we'll also add some logics into that, and then a shuffle command to shuffle those up so we get a bit of randomness of when they get activated. So that could be a third episode maybe. We'll see how it goes. So yeah, thanks for watching, and see you in the next video.